Yeah, so my name is Stefan Reuter, and I'm working as an IT architect for different customers, basically consulting them for transitions that they are applying to their application landscapes. In the past, quite a few that were transitioning from a batch landscape with lots of batch jobs to a more real-time architecture based on messaging.
Okay, my name is Thomas Kruse. I'm a consultant from Germany as well, and I founded the Java user group in Münster together with Garrett. Perhaps you saw some JavaFX stuff from him. And if you want to reach out, you can find me on Twitter. My name is Everflux. Yeah. Okay, the setting.
Good job. Yeah, so let's have a quite short look at the agenda. We'll start with the basic setting, so introducing the different types that you can use to build your application landscape from online and batch and messaging. Then we'll have an architecture overview that shows you the different steps of such a transition, followed up by the actual process of transition and the implications to the technology and to the people that are involved there. Then we have a section on technology choices and frameworks. That's not going to be exhausted, but it's just about what we found that actually worked for our projects. And finally, we'll have some example stacks and lessons learned from the projects that we've done.
Right, thanks. So, if you consider batch-oriented systems and the contrary side, online processing, then you will find they're quite different. In the batch world, you have decoupled systems. They are running on a nightly basis with high latency, so you have to wait until the processing starts. They are asynchronous because they are running at night time when there's low load on the systems, and they are triggered by time, so it's always the same time they run, and there's no other condition triggering them usually. If you want to scale them, you use usually bigger machines and use more resources on one machine to get the job running faster. On the other side, we have online systems. They are tightly coupled and have low latency. Whenever something has to be done, it is directly done in a synchronous manner and triggered by the event which should be processed. Usually, you can scale that easily horizontally by more machines. So you add a load balancer and more web servers, for example, if you are talking about a web-based application. And right between these both paradigms, you find message-oriented systems. They are decoupled. They provide mostly low latency processing, and they can be asynchronous or synchronous implementations. They are triggered by event as well, and you can, as the online systems, mostly scale them horizontally by using more machines. So this provides some features which you don't have in the batch world, and some features you don't have in a pure online world.
Okay, so what we often find is that those people who want to migrate from a batch world, that they actually try to use more online paradigms, and that they kind of overdo. So they have currently batch processes, and then they say, okay, we need this in a more with less latency, and we need the responses faster. So they migrate to an online world based on REST services or web services or whatever currently is the technology of choice for doing online stuff. But then they find themselves in a completely different world with totally different constraints, because they now have a tightly coupled system, and message-oriented actually is kind of a combination of both. So you can combine the non-functional properties of batch with the non-functional properties of online to achieve this. And that's also why we made this box in the middle rather big, because you can do message-oriented much like batch. If you have large chunks and large messages that you are processing, or you can make it almost online if you do very small messages and have them asynchronously processed, but have a client, for example, a web client or whatever, actually wait for the answer so that it appears to the end user as if it was an online call.
So, speaking about the reasons why some organizations want to migrate from a batch world to an online world or to a message-oriented architecture. Some motivations are business-driven. For example, you want to speed up processes and provide to your customers or clients a faster turnaround time so that they get their results faster. For example, if you would order at Amazon something and have to wait 1 day until a batch process is finished, until you get your order confirmation, that's not so convenient and could lead to customers using your support and asking where's my order and what happened. So you want to send them out an email faster. On the other hand, you don't want your customers to wait until the email is successfully delivered to the mail server. So that's something that can be easily implemented asynchronously. Other reasons are leveraging the opportunities of mobile and internet transactions. So you don't really have the batch window at night when you have a globally distributed operation. And you have to go to 24/7 operation. There's just no time to take off business hours, because somewhere in the world there's always business hours and you want to serve your clients. Other reasons could be technology driven. So you want to decommission your current mainframe system, which may be too old or needs too much money for maintenance or too much human resources. Technology reasons here, the same, 24/7 operation should be implemented, or you might even consider migrating to the cloud. And as you all know, in the cloud you have many small systems and not one big mainframe, usually, which you can use for batch processes. So.
Okay, then let's have a look at the architectural overview. So what we are looking here is just a typical system with input data and output data, and the processing between those two. This is usually the situation we're encountering when we see batch processes. We have large amount of input, large amount of output, and processing done in chunks. Through usually complex batch jobs that do all kinds of things. They process the data, they acquire additional data that is required for the processing, and finally they generate the output. So we have batch input, heap of data, batch output, and the processing in those chunks. So for a first step to migrate might be to just keep the input and the output the same, but change how the processing is done. You don't get any real benefits from this, but you can start using messaging internally. You can try it out. You can see how the different how the performance is now different. And you can keep the integration of the system the same, because input and output just don't change. So what do you have to do this? Basically, you need to split the input. So if you have like files or whatever as input, then you could split it into single rows, into single data records. and then let them enter your processing flow. The processing is quite different now, because you don't have one complex batch job, but you have a set of individual steps that are decoupled and that you can connect by pipes. Usually those are in-memory channels if you're staying in one system, or you could use JMS message queues if you want to run it on separate hosts. What you get immediately from this is that you can now scale horizontally, because all those splitted messages can be processed in parallel. Once you're done, you have to aggregate the data so that the output remains the same. Actually, you will just collect them and attach and aggregate them into a file for output.
Yeah, so what actually is important, and we often see with clients, is that they try to directly replace their batch job, which is often one program which is rather complex, directly with another system which is using messages, but still does not leverage the messaging inside of the application. So this gets you the, if you do this, if you split up your processing into separate steps inside your application, you get a decoupling of the steps itself. And you can then easily test these steps separately. We will come back to that later.
Okay, so that's the first step, keeping input and output the same, but replacing the processing. Next step might be to actually change the output. So now you still keep the input based on files, or at least that big heap of data in one batch. Then you split the data as before, process it individually, but the output is now also individual messages. So then you can continue to pass on these individual messages to the next system that also has to be message enabled in this phase. Usually you will find this kind of architecture when you depend on external input. So maybe you have a contractor or a supplier that will deliver you once per day a big file with orders or with status on your purchases or whatever. You won't be able to change that in the first or second step of the migration, because you have external parties that are involved there. So you would keep the input the same, but then you will split the data, do the processing internally based on messages, and output single messages that can be consumed by the next system in your operation. You can also do it the other way around. If you are producing data that is consumed by an external party, then you use your input and based on messages. You do the processing based on individual messages, and then you aggregate the data to generate files or whatever to pass that on to a partner or to another third party that relies on that batch output. Yeah, and that's the final step. If you have full control of the process, then you will have both input and output as individual messages, and the processing also done on those individual messages with loosely coupled steps that are connected by pipes internally.
So you may wonder, why should we do this if we keep the output as a batch, or if we keep the input as one big file? What you get is all the properties of a message-oriented system, where you can use throttling or rate limiting to have a fine-grained control of how your system resources are used. You can scale inside of your corporation better by using smaller machines and even using machines at some peak hours which are not used during these peak hours. This is harder to achieve with batch jobs. So we saw the architecture picture that we have input and output based on messages, and if you are inside your organization and have control over that, you can even between systems use messages as transport for your data. This can be extended inside the systems. You can use in-memory pipes to connect the various steps of your processing. Who is aware of the pipes and filters patterns? Oh, that's not that much here. There was another talk at the Java one. You should have been there. It's the EAI patterns. So we come back to book hints at the end of the talk. So the basic pipes and filters patterns is to have separate steps which are responsible for just one thing. So for example, extracting a value from a row and then passing that on through a pipe to the next part of your system. This is depicted here. The pipes are the pipes and the messages are the small quadrants there. So you have the opportunity to use that inside your application as in-memory, and you can connect external systems, for example by JMS, to pass on the events.
Yeah, so basically what you see is that you can use pipes and filters within a system. Then you have those filters implemented as individual steps, and the pipes just being in memory, passing on of the messages from one step to another. And you can take it to another level where you consider the filters to be systems and the pipes to be JMS queues. So basically it's the same pattern, but it's applied as a different architectural level. And that's actually what we want to show here. So you use the same pattern, but you apply it differently.
Yeah, and this is especially important if you're designing a new system, to be able to test each part of the system and to be flexible by configuration. So for example, there's a new kind of authentication which should be handled, so you can add another step. And all the other steps are not aware of what happens with the data before them or after them. And they don't really have to care about that. It's really important to get this concept on various levels. So we're talking about the transition from batch to message-oriented systems. There are some implications from this transition which we would like to point out now. The easiest part is phase one. You just deploy a message broker, for example, ActiveMQ or some other product. That's nothing you have to really take care of at this phase, but it has implications for all the other phases, because you need to set up an operations team in your organization for that as well. You start usually with some small pilot projects which are migrated to a message-oriented architecture after the message broker is deployed, and then you gain some experience with it, and you learn how to operate that, how to monitor that, and what you need to make sure that the environment fits your needs. That's phase two. After you learn that, you start with a centralized monitoring usually. Instead of just calling one person if something does not work, you have proactive monitoring and alerting systems. You implement procedures in your organization. Sorry. And implement the error handling and escalation procedures in your organization for that. And usually this is a time when you start to stop implementing old-fashioned batch jobs, and everything that is now new will be implemented as message-oriented architecture. You may even start at this phase to actively migrate all jobs to message-based jobs as well, besides of the pilot projects, which should now be running fine. And then in the last phase, you notice that you need something special for your operation. For example, customized tooling, which is not available off the shelf, or special monitoring solutions, or reporting solutions to provide inside data in all your processes. At this phase, usually all batch jobs, where it makes sense, are migrated to the new architecture.
Yeah, usually what we see when customers start migrating to message-oriented architectures is that you have multiple starting points within the organization. There are usually pain points that are encountered by different projects in different locations in the organization, and they all start to somehow experiment with other technologies. And usually when we come in, we already see a bunch of message brokers having been deployed. So one group started, hey, we can just embed ActiveMQ within our application. Nobody sees it, nobody knows it. They're using messaging only within their system. And usually they don't tell anybody big things about that. And then you have other groups that are connecting like ERP systems. All of the ERP vendors also provide some integration stack. You basically get Message Broker for free there, and it's also somehow installed. Or even if you're using an Oracle database, you already have Oracle AQ deployed there. Some people figure out, hey, we can use this from Java with JMS. We can also use it from PLSQL. So you have a bunch of message brokers within your organizations. And so part of that, usually between phase 1 and phase 2, is to actually select one of those brokers for inter-system connectivity and for inter-system communication. And that one will be the one that is then supported centrally by the operations team, and that will be monitored and managed. This is really important because many organizations don't get it. This is a very important infrastructure, and that they have to set up operations team for that. So for databases, it's usually normal thing that you have a DBA or even an own team within operations. But for messaging infrastructure, usually if it's not planned ahead, then it won't happen.
Yeah, we want to show you an example for customized tooling, which we developed for our client. What you sometimes miss is for the message brokers something to really manage what your messages. For example, you're all aware of JMS, I know that, but just to rephrase that, if you have a problem somewhere, your message cannot be processed, or you have an exception in your flow, it will be put to an error queue, and now something has to be done with this message. And you can do that manually with, for example, Hermes or some basic tooling, which is able to use JMS to operate on your broker. But to really be able to support your processes, you usually need customized tooling which can leverage JMS to put this exception message back on track. For example, something needs to be fixed, or there is a data problem where you want to edit the message and then resend it to your queue.
Yeah, basically that custom tooling is something that we found really a good thing to have in the last phase of the transition, to finally convince everybody within the organization that this is a good thing and that it actually matches their business. So this is why we propose to use just something that is custom, that is not based on the technical tools that the message brokers provide, because then it can be even used by some less technical people, because all those messages usually represent a business concept. So you have something like an order or a contract or whatever, and that can be searched for by the data that the business already knows, and then they can say, okay, what happened to the messages, which steps went through that, and as soon as the business people also gain some insight into how the processing is done, they can help fix problems, because they are usually caused by business kinds of things, like missing reference data or wrong mapping or something like that. And if they understand how it works and can look up the individual messages, that really helps a lot. So we'll just show you one example how we did this for one of the customers. Usually it will look different depending on the project, but the concepts should be similar. So you have an overview of the queues, you have an overview of the individual messages, and you see what has been logged for those messages. Yeah.
Okay, that is something I would like to point out at this point. If you have a batch job which fails, it's sometimes hard to trace back what problem was there, and you have usually a complete chunk which failed. If you have a message-oriented application and there's a problem with one data element, this data element can be identified easily and then processed appropriately by escalation procedures or a management interface.
Okay, so what we have here is basically the name of the queue. Those are based on, in this case, business partner names. We see an overview of how many messages have been processed, how many have been are remaining in the queue, and how many errors have occurred. So this is just fake data, so just to get you an overview of what it might look like. Basically, the interesting things are a number of remaining messages, because that's an indication that some processing is slow, or that there are other problems why these messages are not processed. So this is also something where I could add some monitoring for. So, okay, if this exceeds a certain threshold, then you would cause an alert or notify someone. And then, of course, you have these exception messages. Those are messages that actually could not be processed due to some kind of an error. You can then drill down into those messages. What you may or may not see is that some of them are displayed in light gray. Those are the messages that have already been processed. So usually they are not of much interest, because well, they are already done. But depending on your message broker, you can easily configure it to retain those messages for compliance or for debugging or for whatever reasons you want to, so that you may even, if they have been processed in the past, you'll still have them available as a reference and can look up the data. So those that are still available, you can have a look at them. You can see the payload there. So basically what you see is, in this case, it's an XML message. And you have all these headers available. Those are both technical headers, like the user who enqueued the message, or time when it was enqueued and when it was dequeued. But this may also be business information, like a contract number or an order number or an article number, whatever. What we have here in that business domain is usually a user that is responsible for the business process, a contract number, or just anything else. A custom header of the message, a custom value. That's what you can use to search for messages here. Here you can then either delete them if you have messages that ran into an error and you no longer need them, or you can move them to another queue. So if you have fixed a problem, then you can resend that message to a queue to reschedule its processing. What we also added here is to search for log messages. That's basically the connection of each of the nodes that were processing the message, that were executing some steps on them, and they all send their logging data to a central system that stores it in the database and adds the correlation ID of the message, so that we can track down individual log messages to individual messages. That makes it much easier to actually see what the problem, what the cause of the problem may have been. So here we have one correlation ID, the correlation ID of the message that I just selected there. We see all the messages, the log messages that have been generated for that message. So if you click there, in this case it's a stack trace. Yeah, and then you'll see it. It's just log4j output, but with the addition of the correlation ID. And internally, we also use JMS to collect those logging information at one central point. So this is especially important if you're running your stuff in the cloud, because then you usually have lots of nodes, and you can't check the log files of the individual nodes there. Usually, what we see with many customers right now is that if you have a production problem and you have a correlation ID or something like that, that they're using SSH to connect to a server, and then they do a grep, and then they may find something or may not find something depending on whether they have the correct host. And if you also have set up a development system and a test system and maybe something else, then it becomes really hard to know which service to log into to grab for the logging output. Yeah,
and you need technical persons for this as well. So this kind of application allows you that non-technical persons can really easy look up data, what is happening with a customer or with an order, where's a problem, and you can even use this kind of tooling in a higher level. So even this tool is more targeted at technical users, and actually we're using behind this tool a REST service which can be used to integrate in higher level tools as well. So this allows you to search for everything regarding one customer or one process, and that's something you might want to implement yourself. It's not really hard, it's some effort, but on the long term it saves you a lot of time, and yeah, for some managers it's always important to see how is my system doing.
Yeah, that was a good point. The REST service that we are offering with this, that was just a recent addition here. Basically, it just exposes each queue and the number of remaining successful and exception messages as a REST service, and then they can use a monitoring tool like Nagios or whatever they're using to watch out for these counts and alert somebody on duty if it exceeds a threshold. Okay.
Okay, that was the demo. So, as you may have noticed, it's not that easy to move to a different architecture. There are some implications for the operations, what we just saw, but for all your roles in your team, you have additional changes. The way you design your applications changes, at least if you want to do it the right way, so that you are able to test and extend your application for future needs. You should consider using the pipes and filters approach or some of the other patterns in the EAI book. But it's a real paradigm change. You don't think in an online world or in a batch world. You think only about messages and events, and each step of the application is separated and decoupled from the rest of the application. It's just focus on one responsibility. That means that for the development, you work differently. You test this single step. You make unit tests for it, and usually you can really easily do that because the step doesn't have many dependencies on other systems, on other data or external resources. Often it's just really small. You can mock all services and test it really easily. And what we did with our customers is that we started with the paradigm of message flows or job flows in order to design how the application works with all the data and how everything is connected, because one message is really flowing through your system from one step to another step, and at some point it's decided to take a different route and then it flows further. So this is how we think about it. Of course, this sounds really easy, but your infrastructure will become more complex. You have the message broker, which is a new system. You may have more systems which interact via the message broker, and after all, it's more than just one big database or one host. So your infrastructure will become more complex, and you should be able to manage that well. But it gives you, on the other hand, of course, more flexibility. If you have a scheduled downtime, for example, you want to do testing or have to replace some hardware, you can take the system offline. All the messages are in the broker, and after the system becomes available again, it will consume the messages and continue with the operation. And if you want to scale up, you can just add more machines, and all machines will consume the messages from the message broker. The message broker is responsible to handle transactions and to prevent duplicate messages, so that two machines are effectively processing the same message. This is done by the message broker, so you don't have to take care of that. That's really good. Yeah, and after all, you can even go to the cloud and scale up there.
Yeah, basically the cloud scaling actually comes from the parallel, from the feature to be able to execute those messages, those individual messages in parallel. Right. Yeah, then we have some technology choices and selected frameworks. Just I'll look at them. We divided them into four parts. One is development, then the message broker is basic infrastructure, the runtime that you're using to run your steps in, and monitoring and management. So for development, usually you have choice between using a visual editor, as it comes with many ESB products, or you can use text-based development tools. Often we tend to prefer the text-based ones because actually it's much easier to manage them in a source control repository or something like that. And if you have a text-based, you can still generate images and visual representations of your flows there. But both are available. Examples for this are Eclipse with the Spring Tool Suite on one hand side, basically uses XML and provides an option to generate graphics from that, or on the other hand, the WebSphere integration developer, that is a heavily visual-based thing that you will probably use if you use the other IBM products. But you will have your experience if you used it. For the message broker, basically you have the option to either use a central message broker or a decentral one. So a central message broker means that you have a highly available cluster of a few nodes that you will distribute your messages, versus decentral, which means that the broker is deployed to each of your nodes and runs there. You can either use it embedded or as a service externally. And you can decide whether you want to standardize on the API like JMS or on the protocol like MQP. Examples are, well, WebSphere MQ, probably the most widely used in the enterprise environment. ActiveMQ as an open source solution that works really well. And if you're in the cloud, then you are normally tied to the infrastructure that your cloud supplier provides you with. So in case of Amazon EC2, you will probably use some simple queuing service. For the runtime, you can decide what you want to use. Either you have a vendor for your runtime. If you're using IBM stuff, then you will usually just deploy it to WebSphere. If you are running with more custom things, then you are free to decide which footprint you want your runtime to have. So we made a very good experience by just using Java SE with Java Service Wrapper or something like that to actually start up the application and nothing more. If you need additional Java EE things, then you can deploy it to servlet container like Jetty or Tomcat. Or, of course, if you need lots of integration, they can also use a fully fledged Java EE server like Glassfish or one of the commercial products. Basically, the bottom line here is that you should really think about what is required for your steps and for your systems, and go with the smallest that is possible. So really consider using Java SE for running these things, especially if you are in the cloud. You can have some great performance. If you have a very small runtime, then you can use small machines as nodes, and they will have most of their power available for actually doing business work and not to manage the container itself. Yeah, finally, for monitoring and management, you have some of these monitoring and management tools integrated into the message broker. So often the products come with some kind of monitoring, or it's integrated within the runtime. Maybe it provides JAMX or REST-based things, or you go with your own, so or a combination. So basically what we did most of the time is to use monitoring some off-the-shelf, usually open source products, and build our own things for management and to expose the data that will then be monitored.
Yep. The same holds true for the frameworks. Basically, you have three options. The first is do it yourself. You use Java EE with the building blocks, JMS, JTA, and so on. You can really use that and build your complete own stack of a message-based architecture, integration, and transformation, whatever is necessary to serve your business needs. The other option is to use a readily available framework. There are open source frameworks like Spring Integration and Apache Camel. Both are really good and lightweight, so you can go with them and build your complete application using just Java SE and Spring Integration, and then run it in a lightweight container like Jetty or Tomcat. And then you can apply the pipes and filters approach to connect your building blocks at different steps of your application. You have the third option to use a vendor product. Sometimes you hear the buzzword of the enterprise service bus or ASB, and are often more heavyweight but supported and with tooling and vendor support supported products. That depends on your needs. I would discourage you of rolling yourself everything. Just go ahead and use an open source framework. I favor Spring integration. It's really easy to learn and you can start really fast. But if your organization requires some kind of really political motivated or whatever motivated big vendor support, then you can of course choose that. But consider for Spring integration and Apache Camel there is commercial support available as well, so try that first and don't roll yourself.
Yeah, okay, finally we'll provide you with one example of what such a stack might look like and a few lessons that were learned while doing those projects. So this example stack is made of an Apache Tomcat as a servlet container. So this is basically a mid-range runtime. It's not as lean as a Java SE. But it provides with endpoints for HTTP. So if you have to handle HTTP requests that are coming in, or have to offer REST services, then usually you will go with a servlet container. And for that organization, they already had all the knowledge in the operation team to deploy Tomcats, so that wasn't an issue for them. Within that Tomcat, we use the Spring framework for transaction handling and for data access. And finally, Spring integration for wiring. So those filters, those pipes within the JVM that connected the individual filters were all configured via Spring integration, were configured as Spring Beans, as well as for configuration. And well, yeah, Spring integration is one of those frameworks that actually implements the AI patterns so that you have a common language to talk about the concepts. As a message broker, they decided to use Oracle AQ. So this is just a JMS implementation that is available inside the Oracle database that comes for free with it, and that is used internally for replication between different Oracle database nodes. It's quite nice because you can use the same transaction for your database access and for the JMS transaction without having to worry about any things like two-phase commits or something like that. Yeah, so that's what the stack looks like from a brick architecture look. Basically, we have the business logic layer at the top, and then these individual flows. Flow is just a connection of pipes and filters that are providing one use case, if I want in that way. Originally, they were derived from batch jobs. So where you had in the former times one big batch job, then now you have one flow that is split up into different steps that are loosely coupled and then interconnected. Foundation for that is Spring integration as a framework for those flows. Tomcat server that is used to run them, and then Oracle AQ as a message broker, and whatever other systems are to be connected, HTTP REST-based services of other third parties that provide data for the application, as well as database lookup and stuff like that.
Yeah, what is really nice here is that there is only one reason to change your business logic. That is when your business requirements are changing. If you need to connect to a different message broker, or if you need to change authentication or compression or something like that, you do that as one part of your pipes and filters architecture, and your business logic is decoupled of that. So there's no need to change inside of your code besides configuration in the Spring integration level. This is really nice, and yeah, that makes your long-term cost of your architecture lower than if you have a tightly coupled architecture.
Okay, so finally, lessons learned. Basically, 3 items that we'd like to highlight. First thing is the mind shift. Mind shift not only with the technical people, but also with the business people that are involved. And not only for how systems are connected, but also how systems are actually built, because the patterns are leveraged at both levels, at connecting the system and at internally structuring the systems. And not just for the back-end system, but also for the front-end system. So if you have a message-oriented system, then you will not get an immediate reply as if you are using an online system, and but you are getting a response much faster than if you just submit your job into some batch process and next day check if it's done. Next, the effort. That is something that should be really considered. If you remember the 3 phases that we had, phase 1 is usually done within a few months. So you'll get started and everything gets rolling. This is really fast. You have early adopters in most of the organizations that are keen to try out new things, and the question was how many batch jobs that would include with a few months. That's that's a good question, and depends, of course, on the size of the batch jobs. But we usually start out with just 1 or 2 of these jobs, and keep focused on the infrastructure. Then you have phase 2 that usually takes a long time. This is at least 6 months to a year. And then for the final phase, that's a really hard one, until you have convinced everybody to actually change this and to adopt the new paradigms. And this is a phase, that where you can plan at least a year for that. So total time for such a project will be usually between 2 and 3 years at least. Yeah. But you start getting the benefits right away. So you don't have to be completely finished to start having the benefits.
Yeah, but speaking about convincing everyone, there are some jobs that are really best fit with a batch implementation. For example, if you have some payroll stuff which needs to be done at a fixed point in time, you should really keep that as a batch job. As we showed on one of the first slides, you can integrate a messaging architecture easily with batch jobs as well, and you should not apply the golden hammer anti-pattern. So now messaging is wonderful, you love it, and you try to force everything into that. That's not how things work. So keep in mind that there are some problems which should not be converted to message-oriented architectures as well.
Yeah, a good example for where batch is really a good fit is if you have things that are just based on time. So if you have, say, at the end of the month, you are generating accounting statements or something like that, then that's just a batch job, and I wouldn't change that. Of course, you could generate a lot of individual messages for each account that you have, but it really doesn't make much sense. It's time-based, not event-based. So keep it batch if that works for you. Okay, so we're done. Have a few minutes left for your questions. Yeah.
So what are you you know, 100,000 records, up to million records, or more, right? What would be the comparisons then the execution time?
Your question was regarding performance and execution time and throughput. One thing has to be said, of course, that a well-designed batch architecture is really a performant thing. This is really working well, but it has one problem, and that problem is actually scalability. Depending on depending on how you do it, this is at least in our experience, that was something where we had some great success in actually being able to split all the data into single messages and distribute them over a whole range of nodes. So the throughput is only limited by the number of nodes you put in there. And these nodes are usually much cheaper than the mainframes that are used to perform batch processes.
Yeah, and mainframe is a massive parallel system, right?
Yes.
So the scalability comes in the mainframe, but even on distributed systems, I mean, I guess you know, batch frameworks like Spring Batch, for example,
Yes.
where it can scale out perfectly horizontally,
Yes.
right? So, I mean, we have very good results with that too.
Yes.
And I think it's not really the argument that the current batch processing applications have the problem of scalability. I think that's just
No, yeah, that's right. And of course, if batch actually works for you, then use it.
I think it depends on the problem.
Yes,
yeah, that's
indeed.
right. Yeah.
Right, that's what you have said earlier.
Yes, indeed. So there's really no reason to say let's throw out all our batch processes, even if they work. And as you said, Spring Batch is a very good example, and Spring Batch is actually built on Spring integration, so that leverages all that infrastructure and just says, okay, one message mustn't be a single message, but it can be batched, and we can put in like 100 or 1,000 records in just one message and process that. So, of course.
There was another question.
Yeah.
You slide you mentioned Oracle Cube, right?
Yeah.
And I believe by that you meant Oracle AQ.
AQ. Yeah, sorry. I said AQ and I saw we wrote MQ.
Yeah.
So that's Oracle MQ is actually a mixture of WebSphere MQ and Oracle AQ.
Right. My question
Yeah.
how is their enabling their Oracle AQ affect to Oracle performance?
The question was, how does enabling Oracle AQ affect the performance of the Oracle database? Yeah, it turned out that it works really well, but maybe this is due to Oracle AQ already being used internally because it's used for replication, and we are running in a rack environment. So we have multiple nodes of the Oracle database, so every change you make to the database is already replicated to other nodes within that Oracle cluster. We didn't see a massive performance problem there. Of course, you have to allocate for this. Usually it depends on how many messages you'll have there, but our experience was that the performance overhead there was rather rather low.
Okay, and what kind of test approaches you used for benchmark their performance before and after?
The question was how we benchmark the performance before and after. Basically, we just use the actual business use cases and run this with synthesized data.
How many messages per second were you working with?
That's hard to say.
It's depending on the customer. So we're in multiple projects, and some customers are processing high numbers of messages in their infrastructure and some lower. But sorry, we are running out of time. You can grab us on the hall and ask more questions, but we...
Briefly, we can actually reference the EVM announcement of technical keynote. They said, well, times change and hardware evolved very very much. So with a common hardware from IBM, you can do about 1 million messages per second for in-memory caching. So that's really a large amount depending on the message size you use.
Okay, thank you for your time.